All right, so today we're going to talk about inverse trig functions. When you were in geometry, you learned a little bit about inverse trig functions. As an example, if I am given the problem where this is theta, and I know, I don't know, I'm going to use 8 and 17. And I want to find theta, I could set up sine, right? And now, in order to solve this, I've got to use the inverse sine function to undo the sine that's being performed on the theta, if that makes sense. That's how I think about it. It's probably not the right mathematical way to explain it, but get the idea. So what we do, this is our nomenclature for inverse sine. It's just sine raised to the -1. If you want to find inverse sine theta, you're going to see it like this instead of like that. This is the proper nomenclature to talk about the inverse sine. But that's essentially what it's saying. Inverse sine. Okay. So you take the inverse sine of both sides. Try that. And now I know theta equals inverse sine of 8/17. Now, to figure out theta now, I need a calculator. Okay? What we're going to focus on, one of the things we're going to focus on in this section is being able to find inverse sine without a calculator. I'll show you how, and we're only going to focus on those 30, 60, 45 special angles. Okay? So if I've got, and I want to know sine theta, I want to know, yeah, sine theta is 1/2, right? So what does theta have to be? What angle here is opposite the 1? 30. Theta is 30. So we can solve these kinds of problems without a calculator. If I asked you what inverse sine theta of this, what angle is that? First off, what quadrant does it have to be in? Sine. Think of sine. Sine is x or y?
Y.
Y. Where's y negative? Third or fourth. Okay. So if I gave you the interval of 0 to 2 pi, there's going to be two angles here that meet this criteria, right? One angle is what? Third quadrant. What's that angle? What is it in the first quadrant if I didn't have a negative? What's square root of 3/2? What angle is that for sine? This is what you guys are going to just get really good at.
60.
Yeah, 60 degrees. Good job. High five. Okay, 60 degrees, which is pi over 3. Yep. Again, we're going to get good at it. Okay, pi over 3 in the first quadrant. So what's the equivalent? Pi over 3 in the third quadrant. It's pi over 3 more than pi, right? And pi is 3 pi over 3, so it's 4 pi over 3. That's always what I do, is I just convert pi to the right denominator, and then I add whatever I need. So 4 pi over 3 is one angle. And then it's going to be negative pi over 3, right, in the fourth quadrant, which is also in positive angles. What is that? What's 2 pi with a denominator of 3? 6 pi over 3. One less, 5 pi over 3. So it's 4 pi over 3 or 5 pi over 3. Either one will satisfy this answer. If I want this interval. Okay? So we're going to focus in this section on being able to do your inverse sine, cosine, cotangent, tangent of the special angles, to get to where you're really good at being able to say third quadrant, I know it's 4 pi over 3 because it's negative square root of 3/2. You just know. Cosine of negative square root of 3/2 would be pi over 6. And where would cosine be negative if this is cosine? Where's x negative? 2 and 3, right? 2 and 3. And so, again, pi with a denominator of 6 is 6 pi over 6. One less, That's my reference angle. 5 pi over 6 or 7 pi over 6. Those are the two angles that this is true. See how that works? Now that we know the unit circle, we can answer questions like this without a calculator. And you will. Okay. The other part of this section is talking about inverse functions. We talked about inverse functions very briefly in Algebra 2, but let me show you an inverse function in Algebra 2, and then I'll show you how you apply inverse functions to trig functions. Okay? So an inverse function in Algebra 2 might have been, let's just do this. I told you 1 over x minus 5, and I wanted to find the inverse. What was the strategy? Do you guys remember at all? How you find the inverse?
Just swap x.
Yeah, swap x and y. Remember that? Okay, so we're going to say the inverse is, I'll just swap them. So x equals y over 1 over y minus 5. Now I need to solve for y. This is xy minus 5x, right? And I'm solving for y. That didn't work. 1 plus 5x. Y equals that. It's bad math all the way. So swap x and y, multiply both by y minus 5, added 5x, divide by x. This is the inverse of that. Remember that process? Okay, so the same is true when we're finding the inverse of trig functions. If I want to find the inverse, swap x and y. And now I've got to solve for y. So first step here, to get y by itself. Divide by 4. Now what? Inverse tangent. Gets rid of that, right? So now I have inverse tangent of x over 4 equals y plus 3, and then minus 3. And this is really the inverse of the original. So the same idea, but now we're just using trig functions. Okay. On Monday, we're going to learn how to graph inverse trig functions and some important things about restricting the domain. We'll learn about that. But for today, you're just working on finding theta using inverse trig functions, and then also understanding how to find the inverse of a function. Questions on that? Okay. I haven't graded the quizzes yet, but I'll work on that.